For many meteorologists, including yours truly, my interest in the weather began with a fascination with the night sky. And for me at least, that curiosity about other worlds has never waned, and that's why it's a real pleasure to welcome to Weather World today Dr. James Kasting, who holds a joint appointment in the Departments of Geosciences and Meteorology, and who studies planetary atmospheres and is very interested in the search for life outside of the Earth. Welcome to Weather World, Jim.
It's a pleasure to be here.
Very good to have you. So you wrote a book, Jim, a few years ago, How to Find a Habitable Planet. So what's the strategy?
So the best way to do this actually is you have to go to space, because we can't find habitable planets except around one star from the ground. Mostly we have to go to space and build what's called a direct imaging space telescope.
So you put the telescope in orbit, and now you start a strategy aiming at different parts of the sky. How do you start that?
With a direct imaging space telescope, we can look for the nearest stars. So there's already a list of the top 100 candidates for finding habitable planets. So we would just go from one to the next and do a search.
So, it's my understanding that the star other than the sun that is closest to Earth actually has planets around it.
That's right. There's Proxima Centauri, which is part of the Alpha Centauri system. You know, people don't understand this, but Alpha Centauri is thought of as being the nearest star. It's a binary star, Alpha Centauri A and B, and these are both sun-like stars, but then there's a third star called Proxima Centauri, which is a red dwarf, which is also part of that system. That's the one that we might be able to find a habitable planet on, searching from the ground.
So what is the current thinking about just how common it is to find a planet that's just the right distance from its star so that temperatures are sort of in that habitable zone?
Well, the answer to that is not perfectly known for the sun, but we know it pretty well for the M stars now as a result of the Kepler Space Telescope. So Kepler was a mission that was up there a few years ago, ran from 2009 to 2013 in its main mission, and it looked for transits, planets that went in front of the star. And so by looking simultaneously at 150,000 stars for 4 years, they were able to show that about 20% of M stars have planets in the habitable zone, and maybe 10 to 15% of sun-like stars.
And so by M stars, you mean what?
M stars are the red dwarfs.
Red dwarfs, okay.
Right.
So what is the best remote signature that suggests that there might be life on a planet? I mean, is there something you can look for in its atmosphere, for example?
That's right. So on Earth, first of all, it's probably easier to look for Earth-like life than some kind of a hypothetical life that we don't know about, because for Earth, at least, we know what to look for. Oxygen, you know, our atmosphere is 21% oxygen. You can see that spectroscopically, and you'd like to see a reduced gas like methane or nitrous oxide at the same time.
And are there, I guess the right terminology would be false positives, things that might look like life is there, but that turns out not to be?
So we worry a lot about false positives, especially for oxygen. And you know, there are some obvious ones. If you take a planet like early Venus, Venus is closer to the sun. We think it had a lot of water vapor when it formed, a lot of water, but it lost that because of a runaway greenhouse. It probably, you know, water is H2O, so it lost the hydrogen, and the oxygen would have been retained. So Venus may have built up an oxygen-rich atmosphere for a while, and that's a fairly obvious false positive.
About a year ago, you testified in front of a House committee on science, space, and technology. What was the main message you wanted to drive home to those Congress folks?
The main message, you know, my main message for the last 15 years has been that we want to fly a big space-based direct imaging telescope. And let me just say, you know, direct imaging, what that means is you're looking not for transiting planets that are going in front of the star, but for planets that are going around the star, and you look for reflected light or emitted infrared radiation from that planet.
Gotcha. You know, as findings on the topic of life beyond Earth make it into the media, they seem to get hyped. I mean, where does this really stand at this point?
Well, it's all science fiction, you know. So at this point, I grew up reading a lot of science fiction. That's a large part of what got me interested in science itself. And you know, we still are at that stage, but you know, we accept that we know that there are planets out there that we didn't know for sure. We know that there are planets in the habitable zone, but we don't know what the nature of those planets is yet.
Gotcha. Before we finish up, you're wearing a shirt that says Project Blue. Tell us a little bit about Project Blue.
Project Blue is a crowd-funded, not yet funded, but hopefully crowd-funded private space telescope to look for planets around Alpha Centauri A and B in the habitable zone. You know, it's this very special case because that system is so close, it's only 4 light years away. You can do it with a relatively small space telescope. So you might be able to get private money to do that.
So if this project is funded, some of our viewers could very well get involved.
They could. So, and we, on the Project Blue team, we would be delighted to have any and all of you participate in this mission.
Stay tuned. Dr. Jim Kasting, thanks for stopping by. And we will be back in a moment with a recap of our short-range forecast.